Hello, my chemistry faithful. Video number 3 for acids and bases. Today we are going to look into the theories. You will be able to explain the behavior of acids and bases using Arrhenius theory as well as the alternate acid-base theory, which is called Bronsted-Lowry. And let's get right into it. Hopefully this doesn't take too long. First, what on earth are acids and bases? All acids are compounds that react with water to produce an acidic solution. Bases are compounds that react with water to produce basic solutions. So we are going to be dealing with solutions. We are going to be dealing with molarity. It's kind of like solutions part 2, except for we're going to deal with very, very specific kinds of solutions. Arrhenius theory, the first acid-base theory, states that acids are compounds that release H plus or H3O plus ions as the only positive ion in solution. And that is much like the definition we saw of Arrhenius theory in the vocab. Remember, H plus and H3O plus are the same thing. They are synonymous. Okay? Bases are compounds that release OH minus as the only negative ion in solution, according to Mr. Arrhenius. And here is a quick picture of what is going on with the hydronium ion. And you'll see again that there's an H plus hooking up with an H2O to make this ion called hydronium, which is H3O plus. So the reason why they're synonymous is if there is an H3O plus, that means there must have been H plus in solution. And as long as that H plus is going on and off water, that H plus is around. So H3O plus and H plus are the same thing. Okay. Formation of hydronium. This is kind of how things work. Just I would write this down the best you can. You don't have to fill in all the bottom pieces, but you can see HCl loses the H. It donates its H to the H2O, making H3O plus and Cl minus ion. The other way you could write this as products are H2O plus H plus plus Cl minus. And that is me literally taking the first picture that we just saw a minute ago and saying H3O plus equals H2O plus H plus. Okay, so that's how I know I formed an acidic solution. Hydronium ion in solution is acid. Formation of an Arrhenius base. Straight up dissociates like an ionic compound, Na plus OH minus, forming OH minus in solution. And it directly forms it because OH was in the original compound. So this is where Arrhenius came up with his theory of what a base was. Okay. General rules. Acids produce H plus in solution, and H is usually the first element in the chemical formula. So H2SO4, HCl. You look at the common acids and bases, they all have H. They all start with H except for one. Okay, there's always just one exception, usually in chemistry, or a lot of times there's just that one exception. Bases produce OH minus in solution, and OH usually ends at the chemical formula. You'll see that there's only 4 bases you really need to know about on common acids and bases table, which is I think L and M. So bases is M. Table M only has one that doesn't have OH. Most of them do directly in them, and that's why Arrhenius's theory works for most things. But there are problems with Arrhenius theory. There is a base that doesn't have OH in it in its formula, and you can see it on table M. Go look it up. So it can't produce this OH minus directly the way he stated it. So all we had to do was modify that theory a little bit so that it actually held true. And so around comes Bronsted-Lowry. So this alternate base theory, acid-base theory, is needed to explain the behavior of NH3. I'm hoping that's the one you found in the base common bases that doesn't have OH in it. It has NH3, no OH. And these compounds do not obviously contain H plus or OH minus. There is one acid that does not contain H plus at the very beginning of the acid's name. So it doesn't just directly dissociate out. So here come the alternate acid-base theories. It is called Bronsted-Lowry. any compound that is able to donate an H plus into um, to a water molecule, making it H3O plus. So if I can donate H plus, I'm an acid. That does jive very well with Arrhenius's theory. The Bronsted-Lowry theory says any compound that's now able to accept H plus ion donated by an acid. So a base is anything that can accept an H plus. An acid is anything that can give away an H plus. So notice now the alternate base theory doesn't mention OH minus anymore at all. Everything is based on the hydrogen ion. Either I produce hydrogen ion and I'm an acid, or I gobble it up and that makes me a base. And remember earlier in the first lesson, I talked to you a little bit about how they're opposites. And this is kind of why I was getting there. They are opposites. And we'll get into the titration equation later. Specifically, the alternate theory talks about NH3. So I'm going to show you a picture here of what's going on. NH3 molecule on the left, and there's a water molecule, and the arrow is pointing to that one hydrogen on the water molecule. So the NH3 is going to accept an H plus from the water. This leaves now NH4 plus, which is called ammonium ion, which is on table E, and this OH minus, which makes it a base. Okay, I don't want you to get confused with the acid too, but underwater it is. That's conjugate acid base stuff, and we're not going to worry about figuring out who's the conjugate acid and who's the conjugate base. I just need you to know that NH3 does not have OH in it directly to dissociate out. What it does is it accepts an H plus, leaving behind an OH from the water, and so it creates that OH minus. It just does it indirectly. Now we have a new alternate theory that is more encompassing of all bases and all acids. Okay. Identify examples of identifying these things using the tables. So notice here's table K, and notice all of the acids do just about start with H. The only one that doesn't start with H is Cu and CO2. And there are alternate formulas for those that, of course, do start with H. When we pick these things out, HCl, check it, put it in water, it's going to form H plus Cl minus plus H2O. Now, I could combine the H2O and the H plus and make that H3O. I could have wrote there H3O plus Cl, and that would also work. If you want to write less things, you'll want to write H3O plus. You can write literally less compounds. Let's do another one. H2SO4 plus water goes to two H pluses, SO4 minus, and H2O. So these are special covalent compounds that dissociate. Forming two H pluses, we call that diprotic. Di as in two, protic is H plus is really a proton. So the first one is a monoprotic. This is a diprotic, and there's a triprotic. H3O-PO4. Okay, now we're going to go to bases. There's only four bases you need to know. This is all of them. Notice that three of them do end in OH, but there is that one that doesn't, and that's why we need that other theory. So NaOH becomes, in water, Na plus OH minus. So I'm giving you a hint about the ions that these things form, because that's part of the practice that you're going to have to be able to do. And I could tell last unit when we were talking about raising the boiling point and lowering the boiling point, figuring out the kinds of ions that these things would form was not easy for everyone. The reason why I know OH stays together, polyatomic ion table E. Back when we go to H2SO4, I know SO4 stays together, polyatomic ion table E. Polyatomic ions do not break up. This part I'm comfortable with you knowing. We just got to get better at pulling those out of those actual molecules that are bonded so you know what ions it breaks back down into. Okay, and I think with that, oh my God, we are finally finished. See you in class tomorrow.